And then do I want to be sharing my screen with it too?
Yes, share your screen and I will just make your screen full screen.
You'll figure it out. Okay. Share screen. Hope you all enjoy this part. Yes.
Oh, while we're waiting, did anyone not get a group?
Oh. Is that working? Is that the right thing?
That is the right thing.
Cool. All right. Hi, everybody. I'm Alex. Nice to meet you all. I'm going to be talking about something that something I'm calling the database first web architecture. Get excited. So sorry, this isn't going to be just JS. I'm going to be talking a lot about SQL mostly, actually. Yeesh. So just as like a read of the room, I want some hands. Anyone know that you could make an auto-updating column so you can get your updated at magically every time you update an object in your database? Yeah, that guy knew. I knew that. I knew someone would.
Yeah, Rails does that.
Yeah, Rails does that. If you're not using Rails, if you want that some other way, if you have a Go thing and you're like, oh, I have to architect this whole thing that I saw in Rails and I just, that's all it is really. Soft deleting table. If you want to make sure that no one can ever delete something in your database, there's your trigger. I promise it works. It's great. That way you use the delete function. You just say like, the same as any old delete command, and it won't delete the thing, but it'll delete it to now. Pretty helpful things. Though might seem totally crazy to you. You're like, well, we use JavaScript or Rails or whatever to do that. Anyway, we're gonna step back for a second. That was just a little context. Oh wait, did anyone raise their hand for the second one? No, okay, fun. Okay, so this is gonna be a little weird sounding to many of you, but follow me. All right, so we're gonna talk about three different general architectures. The first is a static site. This everyone knows, we've used static site plenty of times. Make it in Vue or React or whatever you want. It's come back, it was the original thing back in the day before we had really dynamic things, the old-timey Wikipedia. And then we started using dynamic sites a lot more. And then now we've been sort of focusing more on thinking of front ends as fully architected things that might have many things they connect to on the back end. So this is sort of the way of thinking about it. You can easily make a large burden on the user's machine, but anyway, whatever. And obviously, we have many ways of storing long-term data. Anyway, so now we jump to back-end server-side rendered sorts of things like Rails and Django. They're very well tested. You get a back-end. The key here is that the focus of a back-end of a server-side rendered app is the back-end is your main product, right? And you have a front end to display that back end. And you might have databases, but you might not. Who cares, right? You probably have an ORM. The back end is mostly about constructing this conversation between front end and ORM database. We try and obscure away the database as much as possible in these sorts of things. Here now we're talking about this database first architecture. And so what I really want to think about this as is the database is your product. the backend is a middleware for connecting to your database. So if you ever heard good old-fashioned MVC, model view controller, in all of the other kinds of architectures, you often end up making model view and controller in your front end, a model view controller in your back end, maybe even a model view controller in another front end that also connects to your back end. You can see how that scales. We really want to think of the front ends, possible multiple front ends, maybe just one, as your views. Those are your view layers. Back end is really the control layer, and the database does the models, not the back end. Anything can be replaced except the database. So if you've ever worked with Rails, it's really easy to swap out, like, oh, we're going to throw away this SQLite thing. We're going to put in a MySQL thing. Oh, we're going to swap that out with a Mongo thing, whatever. I want to think about it the other way around and say, like, your database, that's your product. You can throw away a back end. You can replace it. You can throw away a front end. You can replace it. We can't throw away the database. And then with this, I like to give the front end a full-on framework, make it nice and pretty. You can't skimp on that because that's what the users at the end of the day interacting with. So your database is your product. Sorry, we're kind of going out of order. I kind of ramble. So yeah, anyway, that's a segue. So why is your database your product? It's because competitors can copy your front end. They can copy your back end. They can buy more infrastructure than you have. They can't copy your database. Like that's the magic there. You may version or replace your backends, your front ends, but you don't want to replace your database. Trust me. Well, you don't have to trust me, whatever. Form your own opinions, I mean. But it sucks to replace your database. And that's the hard thing. Your database is the source of truth. It is. You can try and have other things be the source of truth. It's not going to work out so well. You never will check authority, like who is allowed to do what, closer and more correctly than if you do that in the database itself. Consistency is important. Whether we're like connecting to your database via your, even your backend, or you're connecting, just SQLing in, or you're connecting via a different backend, whatever. It's really great to have consistency. And then let's see. And then the last point is that your front end, like at the end of the day, most of the time, your front end, it's not calling. Most of the time, your front end is really calling just for data, right? What's the front end there? It's to give the user a way to interact with whatever you have in your database. It doesn't really care that there's a backend in between. So let's keep that simple. Okay, now we're gonna actually see some code, so yay. Okay, and this is actual JS code. So treat the backend as if it's an adapter for the front end. Your backend has knowledge about endpoints. It can figure out what's required and stuff, but it shouldn't, in this design, really have knowledge about models. It can talk to the database and let the database decide those sorts of things. We're going to avoid reformatting in middle steps and just output the database directly to the front end, or the response from it. And then we're going to be intentional about what we're allowing to take time and what we're not. Okay, so we're going to go through this for a hot second. So here, this is given a method that you can call from the front end, like any old backend method. It's got a constructor, so obviously that happens first, and that does, you can't make a constructor async, right? So that has to be instant validation, so you can have requirements on parameters, whatever. And then we have this run function that's where we're essentially, passing off the request to the database. So we have a query called update Fox awesomeness, and we don't know what that does in this method, that's where the special sauce comes in. Here, obviously, we do have this session object. You can see the session.id there and the arguments. The arguments have been validated as they come in. The session, that is the caching piece that the backend can do. You can do it your own way, but there is obviously some meaningful middle layer there. And then you can see, I mean, we're getting a result and just responding with that result. That's your answer. I put another notify step in here. Oftentimes you do want to be able to have some asynchronous processes. Something, obviously the database isn't going to send an email on its own. So those are the things that can run after you've closed your HTTP connection to the front end. You've responded, given it its thing, and then this can run as a separate process. Send an email. Now here's where the query gets to do the logic. So instead of, you look at this Fox awesomeness, that's just an insert, or we're calling it update Fox awesomeness. You'd expect it to be an update call. But this one, we want it to be versioned. It's a magical versioning thing. So your database can handle object validation and authorization. We're not going to be afraid to make big gnarly queries. Okay, that's the come with me, enjoy the queries. They're beautiful. The thing about it is that the JS, what you can sort of think about it as a balance is you don't have to write big ugly JS. You're writing big ugly queries instead, and it's one or the other. But in this case, there are reasons to do this one instead. So here, I'm gonna just talk through it for a hot second. We're inserting into Fox awesomenesses, that's good, where we're going to check that the session ID is allowed to do this right here. So I'm going back for a hot second. So you're passing in your session ID that corresponds to some sort of token that you have on the front end. There's your cookie, there's your session. That tells you who's allowed to do what. And you're trying to update a Fox ID by setting, some number that's awesomeness, right? So right here, what we're doing is we're checking. Can you see my cursor maybe? Yeah. We're checking that Fox has a human who's friends with the human that's the owner. Sorry, that's the owner. And then, gosh, sorry, that's cutting off at the bottom. You have to make sure that, the one human owns the thing, owns the Fox, or the other human owns the Fox. Here's the check where session ID equals 1, Fox ID equals 2. We're making sure that the awesomeness is greater than 0, and that the awesomeness is not greater than the awesomeness of the human who is rating this Fox, right? So we can do interesting checks there, and then returning star. So that's where you can send it back. Now, obviously, I know what you're saying. You're saying you just did an insert. You might already have one in there. Where there's clearly more going on here, right? Time for triggers. Okay, so we put the important logic behind the scenes in the database using triggers, so that this can be as simple as we can make it, in a way that understands the context of who is trying to do this thing and what they're allowed to do. Now in the trigger, we can validate and do other things. So in this case, we're updating the previous Fox awesomenesses by setting an outdated at now whenever a new Fox awesomeness is replacing them. So that creates a versioning system that ends up living in your database, very easy to do and use. PG CLI in or whatever your favorite way of going in, and you can just whatever, I'm inserting things, and every time you insert something, it versions it. I personally recommend strongly against using special functions in writing queries, because when you're writing a query with a sub-function within it, it gets in the way of the optimizer. It gets it way less flexible because functions have specific intakes and outtakes. They don't work with views really nicely, things like that. But put tons of triggers all over the place. Put triggers on inserts, updates, deletes. They're really awesome. They allow you to make your database act the way you want it to act, and so that you can just fiddle with it. You can do destructive things, and it'll take care of it. You don't have to be afraid to, should I update this thing? Well, whenever I do using Rails, it'll tell me problems, but I really want to just try and update this thing. Well, it can do that for you. Downsides. Yes, there are some of these, as it turns out. Okay, so you don't automatically get types. This is a real pain if you use TypeScript. All you out there. Different languages, SQL, so it encourages siloing. So you're not going to have your whole stack in SQL, because that's not how that works. So we're definitely requiring that some people in your team know how to write SQL, and some people are going to be writing something else. And so that encourages siloing, which is, it's not necessarily the end of the world, but it can be kind of a pain. Everyone wants to solve their problems their own ways. Anyway, engineers are really attached to ORMs. ORMs feel warm and fuzzy for so many engineers. Even if you don't feel warm and fuzzy about it, you recognize that hiring gets really hard when everyone's like, wait, you don't use Apollo? And then it can encourage over-systematizing. We've ran into our team, we've run into many times where someone's like, okay, wait, I could make a trigger that checks that table and takes that table and does this thing and does that thing and does this thing. Well, let's do all of the things. And it's like, well, you need some balance sometimes. So real world findings. So I should mention what my stack is right now. So we have Vue.js on the front end, Node on the back end, and Postgres in the database. The things that I showed you just a few minutes ago are actually like chunks of code that I copied and pasted and changed words for. So that's legit. And we've been running this system in production for, it's been 1 year and a couple months, with paying customers and all. Okay, we've been able to build really quickly, focusing on one thing at a time. So, you can understand that our back end is as minimal as possible, right? It is just a simple system. People in our team, they either need to write interface on the front end or SQL, and that's pretty much it. So it's really quick to be like, okay, I need this one value added into it. Okay, it's one file we change, What we've also found, people often write a first pass in JS, then a second in SQL. So sometimes you'll see a method will balloon up and then it'll shrink back down, right? There's no harm in writing it kind of garbage the first time sometimes. So sometimes we'll pull something out of the database. It's like, I suck at pulling it in the right format, so maybe I'll just do a reduce before sending it to the front end. It's not a big deal. Everyone breaks databases, everyone fixes them. This has been huge with more junior engineers, is that more junior engineers break things, obviously, and they're able to fix things because everyone's learning SQL and everyone's like, it's not just like the one database person on the team. we're much heavier in that regard, which means that our junior people fix my mistakes all the time. SQL, Postgres has such good documentation. That's like, as much as you may be like, oh, my thing, React has such good documentation. Yes, it's true. And SQL has way more. It's really a well-designed system, and lots of answers to your questions. Junior engineers write inefficient queries, but it doesn't matter much, and it's easy to fix. So that's been huge. Like if you write something really inefficient with tons of looping in JS, you're gonna get something slowed down. Whereas even with lots of looping, which you can write loops in case you didn't know, but don't in SQL. Even if you write something with tons of loops in SQL, it doesn't slow things down that much because there's this the Postgres optimizer is just like the most beautiful, fantastic thing. Anyway. So it takes a really big load for those to really slow you down. And once that happens, you're like, okay, cool, I can just join a little better. When it comes to doing charting or other sorts of aggregations, it's so fast. It's so good. It's like if you really want to make your charts, your data, changed into a different format and show up really quickly, don't use D3. Don't like send all of your information to the front end and then figure it out over there. Like we have SQL. Like SQL is a beautiful, wonderful language, and it's made for this. You can write charts really quickly, and they can be really fast. Even we have like a year's worth of data that all of a sudden we're like, I guess I want to make a chart that goes by the month and does all this nonsense, averaging and whatever, and you can just write that in SQL so easily. Okay, and then without a complicated backend to maintain, we're able to focus on front-end logic, which is really good for user experience. Like at our company, everyone was hired as a front-end engineer, which except for me, and we're just able to move really quickly, follow, make things awesome and super fun. All right, thanks. This is just a picture of my team. They're all saying hi. They're all friendly people, waving shoes or something. They're very supportive. This was mostly my brainchild, and I forced them to do this, and it's been really great. So thank you all you people in there. And then thank you. Questions? Yeah. Go.
So I know that everything is kind of query based and like your responses are based on the queries, but I was just like curious if the system actually gets better or trains itself based on those queries and like previous responses and the data that you're actually collecting.
So if I hear you correct, so you're wondering if the system itself that we've built, our infrastructure, does the same queries more efficiently as it goes by figuring things out in some way. So yeah, this is a great. So yes, very much. The Postgres optimizer, if you are not super familiar with it, does a lot of magic under the hood. Postgres does tons of caching is one thing. And so that's the simplest thing is the caching part of it. If you try running a query and then running the same query a second later, and it knows that there haven't been any mutations, it'll send you the same values that it got last time. It doesn't do this on a large scale. There are what you can do to make things, and it's not automagic like I think you might be hoping, but you can do, if you have like this one query that you run all the time, you can materialize a view. There's materialized views, which is essentially like you can think of as a virtual table that when you can like you update this table and then you rerun it, and it's maybe based off of 5 different tables with like averaging or whatever. So that's really helpful once you get into really heavy charting and you're, you know, and your query is just not cutting it because you have so much data. So you materialize a view that sort of just like gets you the answer right there. You can also use functions, but functions at that point end up being less efficient, and they're not as flexible because you can't like query on like you can't essentially query on the function. You query on a materialized view, which can allow you to still have the flexibility of being like, okay, now I want to sort by, you know, age or, you know, color or whatever. Cool.
Thank you.
More. Yeah, go.
How are you doing testing?
Yeah, so testing, that's a good one. We, at our group, we are at this point fully end-to-end testing. So we're not doing any unit testing. That's mostly because of like the speed and what we're trying to focus on. But the way that we do testing is we deploy things to review environments and have tests run on those review environments. So we have a whole setup for that. Does that answer? Do you have more?
Yeah, and follow-up question. How are you organizing all of those queries?
Those queries, what we have, our sort of adapter is those queries are in SQL files. You know, each query is just a SQL file, which is really nice for formatting. You know, you can like, you want your text editor to display it nicely when you're doing that nonsense, right? And then we have a database object in the back end that just looks in those files and aggregates them all and imports them based on their name. And then you just, if you look at this fella right here, you can see query database update Fox awesomeness. So query database is a function that calls that object and finds that essentially a file named update Fox awesomenesses. Does that make sense?
Last question, I promise.
Yeah, do it.
Like composability, like I would think there's probably some things like you mentioned,
Yeah.
authorization,
Mhm.
that is like the same thing
Yep.
over and over and over
Yep.
again. Are you able to do that in such a way where you can like reuse the thing you've already written once, so you don't need to rewrite it like 100 times?
So for queries, the answer is pretty much no. We do have, as you could have imagined from the question where I keep on mentioning views, we do have some views that are reused in various queries. So like we have like employees table and maybe the picture, you know, your picture, you want it to come out as the one that is listed, or if it's null, you take the UUID and run it through something and come out with a random looking number, and you get the picture based on that, right? And so that sort of thing is in a view that we then use the employee's view in a bunch of other queries. So that's sort of how composability works nicely with views. With the backend, I mean, pretty much everything in every method in our backend goes through the same process, right? You get the session, you validate the session is good, you validate that you have access to all of these things, and then like you try each one of them, or you try, not each one, but you figure out what method you're trying to run and you do that method. Honestly, we don't have much more than this is one of the bigger method files that we have. So composability really, you know, once we get to this level of it, I don't want to have some nasty abstraction of more JS that we're now calling that to call back other things. Like most of these things, I want it to be as simple as possible because it's one function that, that we just want it to be as simple as possible and let the database do the heavy lifting. So, yeah. Go.
How would you do code review with a scale framework?
We do a lot of code review. So I assume that the bulk of the question is if someone is SQL heavy and someone is not SQL heavy, and like who gets to review what. Cool. Thanks for nodding. So the bottom line is that in our group, it's I have a strong passion about polyglot work and everyone trying to push everyone to be as full stack as possible. People like to silo, and I think that's good. Like silo the way you want to silo. And so in our team, essentially when you make an MR, you tag a bunch of people, who you think would be good for reviewing it, and you tag a bunch of people who you think would be bad for reviewing it. That's like the rules of the group. And so when you go to review a thing, if you're not good at reviewing it, if you have the time to learn, that's your chance to learn. If you don't have the time to learn, you can always pass it off. So in our team, we make sure that everyone feels as interchangeable as possible, for lack of a better word, by encouraging people to review that thing that's, you're a front end person, you're all about, dynamic SVGs. Well, now you get to look at some SQL, see what you think of it, right? And sometimes a reviewer just says, I don't get what's going on here. And that's just as important of a comment as you don't get what's going on here, right? You can teach, you can learn. If it's hard to understand SQL code, then maybe we can make it easier to understand. Anyway, does that answer pretty well? Okay. Yeah, go ahead.
Yeah, time-wise, performance. If you run the same computation in front and then the database, what are you seeing?
Yeah. So one thing, it's not everything is so obvious. Sometimes you'll look at a query and you're like, oh, obviously this is going to be really fast and we're going to do it this way, and then you benchmark it and it sucks, right? We do a lot of checking other people's work, but with benchmarking and things like that. That's one of the things that happens in code reviews is I'll be like, I looked at the old way and I look at the new way and it's not so hot. Or hey, actually it shaved all this time. I am trying to think of what the numbers to give you. What I will say is that I'm not going to give you any numbers because I don't have them on the top of my head and I don't want to just be lying. But what I can say is when we have had issues, they've been really easy to fix. So, and most of the issues have come from, you get a bunch of data, you pass it off to the front end. Now the front end has to display it slightly differently. And so we have to, reduce and iterate and whatever to make this, thing that came as an array into an object so I can display it in this stupid form, right? And those end up taking the longest and crashing browsers and stuff like that. And so oftentimes we spend a lot of our time trying to make the back end actually respond with the object that the front end wants. And that, when we get it right, it's beautiful. It's really fast. But when we have, but I would say that just if you're not super familiar with it, the thing that is the most nasty about SQL is that it's fundamentally, at the end of the day, not like a programming language, in that programming languages have an order they do things in, and SQL does not, right? SQL, you have a bunch of tables, and I'm giving you instructions for how I want them to be merged at the end. And I'm not giving you instructions on how to do that. And so that's where the optimizer comes in, and the optimizer does all the thing as quickly as possible and whatever. But I think the thing that's been the one place where we have moved away from doing everything in the DB has been whenever a call, there were some of the charts where it was okay, we'll grab the chart data and average them this way and take a sum total in this way and spit back out these like 5 different kinds of responses, if that makes sense. So it'll be like, you know, a time series list, and on the side, what you can think of as like a side loaded like total number, which will be counting up all those things, right? And when doing that, we found that it took a lot longer, because what ended up happening is, this is my guess at least, is the optimizer was able to put all those together, but it had to essentially do the first step before doing the second step. And whenever you dictate the order of it, it gets sucky. And so we found that doing it in 2 separate queries was faster in that regard. Or just like get the time series and get the total, and you can do those, you know, 2 different DB calls at the same time. So sorry if that didn't answer very well. Go.
So just out of curiosity, so other than simplicity and the speed, is there any other reason to use SQL versus any other languages?
Mm-hmm.
I have one more question though.
Okay.
So, how would you like, how do you think you can actually improve this?
Mm-hmm. Mm-hmm. Okay. Let's see. The first one first. So you're saying that. Sorry. Can you say the first one again?
Why SQL?
Why SQL? Instead of other languages? Yeah, for doing. So I love SQL. I think it's beautiful. It's the thing that I think is the best about it is so flexible, right? If you've ever worked with, you know, I would say the equivalents, if you've worked with like pandas or D3 is, you know, our JS1, of course. Or if you've worked with R or some other statistical language, I think that SQL is very elegant, it's very fast, and it's very extensible. Database-wise, I find it like it's really easy to change how your database works rather than a NoSQL database where you're like, okay, well, I have to store all of these columns in order to make everything indexed in a reasonable way and selectable in a reasonable way. The thing that SQL gives you is the ability to, as I keep describing this optimizer thing, to pull tons of data in a different fashion than you put it in there, in a different fashion than you planned 6 months ago, really quickly. Does that answer well enough? Yeah. And then the second one is how can we do better? Honestly, so the first thing I have to say is that I was astounded by how well it worked right off the gate. So this sort of architecture was, the back end in particular, I wrote pretty much by myself in like a couple months and stood it up, and we've pretty much mostly only touched the front end since, right? The back end, we've like migrated the database and changed how the database works, but the actual back end piece as like the middleware that like does all the connecting has pretty much not been changed very much. And I think that's cool that it's working well. I think the thing that we as a team need to change is mostly not like covered in here, is mostly I want to be locking down our types that we respond from the database with. I want to make sure, and this is, maybe I should have put this as a caveat, right, is that you have a little more flexibility than you need, right, than you want, right? It gets really kind of nasty for the front end when the front end is like, okay, well, I can ask for this tree of data, and then the back end gives me this like really awesome tree that I can display my whole page in, and there's like to-do items in this tree. And if I click on a to-do item, then like I get more data from it because that was just the metadata of the first one. but the more data doesn't fit the format, the same format that my original tree came in, right? That's maybe I write component A that displays it one way and component B that displays it another way. And they just have to use the different formats. And it just like having non-consistent formats for objects just kind of sucks. And this allows you to very easily have non-consistent format. I'd like to change. I don't have all the answers on that one. So, anyone else? More questions? I can be done. All right. Thank you, everyone.
You're in the show.
Can they see everything on my screen?
You need to share your screen.
All right.
Down at the bottom.
There we go. Sure. There I am.
That's you.
All right. So kind of close to the last time we met, and since the last time we met, Chris gave an awesome talk about how awesome the web is and how much easier it is to use now. And I kind of want to piggyback it because it was such a good way to demonstrate just all the advancements that have happened since we kind of started coding, some of us for decades now, but it's gotten easier. And just to introduce myself, I am Cody Wilson, and I have been developing for about 10 years. And I want to, again, piggyback Chris's talk about the web is good now. But instead of the web is good now, I want to talk about something Chris didn't get into, which is 3D on the web. And the title of my talk would be 3D on the web doesn't suck quite as much as it used to, because I definitely wouldn't call it good. It's fun. It's way easier than it used to be. So I just kind of want to get into and highlight, if you've ever been interested in 3D on the web, some learning opportunities, some fun projects to look at, and some inspiration. Because there is a lot of opportunity out there. This is going to be a pretty informal talk. I just have a list of websites to kind of share with you and show you some examples of how I've used 3D on the web. So let's get into it. All of you have probably seen 3D on the web in some form or another. The most prevalent example I can think of is the GitHub homepage, which uses this pretty cool experience where you can see live commits happening on a globe that's super interactive. You can spin the globe around and check out these huge arcs where people are committing from one location to a repo that exists in another country. And really, 3D on the web, this is a great example of it because it just elevates the experience. You could have a list of just text, this person's committing, but to actually see this, it communicates just so much more than just like simple, than you could simply do with HTML and CSS. So that's a good example of it. You've also maybe seen on the popular site Awards, which awards excellence in web development. It seems like almost every site has some 3D component to it that they award. And just to illustrate that, I'll look at the technologies used, and When you take a look at this, you see that React is on here, and it's got 1,000 tags. But when you look at the most popular 3D library, 3.js, it's got 1,245. And then the most basic level 3D way that you can implement, or that you can implement 3D on the web. Oh, it's jQuery. I didn't even see. Oh, Jesus. We're going to pretend we didn't see that. Oh, man, that's funny. But WebGL is the most basic form of 3D on the web. It's also the hardest to write, most time consuming. But we're going to focus on this other library called 3JS, which kind of makes WebGL easier to use. For those who don't know, WebGL came out in 2011. Its last release was in 2017. It's kind of no longer being supported. I think its predecessor is called Web CPU or Web GPU, and it's gonna just make use of how GPUs have changed over the last decade. But there's also, if you don't want to write WebGL, because if you were to try to write WebGL, something as simple as like rendering a sphere that you can interact with, like that we saw on the GitHub page, is like 300 or 400 lines of code. We're going to look at 3.js, which takes WebGL and makes it much easier to use. It's like an API to say, hey, render me a sphere in like 3 lines of code instead of the 300 it would take with WebGL. Let's look at some examples of 3JS. They have this awesome homepage with a bunch of examples. You may have seen when it like first came out, it was kind of popular for doing music videos. There's one from Ellie Goulding, Lights, that was like super viral that came out. But the most recent one, and they haven't updated since, was NASA used it to talk about and demonstrate all the complicated procedures that happened when they landed on Mars in 2020. The maintainer of 3JS was like so proud that NASA used his library that he's kind of just stopped using examples because he wants that to be the most prominent one. So yeah, if you stick around and watch this whole thing, it's pretty awesome. It goes through all the most complicated phases of what happened when NASA landed on Mars recently, and like it's super, let's see here. Yeah, it's closer and closer to Mars and shows you all the stages. It's pretty awesome to watch. You can like zoom out and see the path that it took to get there. And that's the kind of experience that you just can't get unless you're doing these 3D renderings where you can let someone, zoom around. And they even have like the secret binary message that was encoded on the parachute up there, which was really cool. I can't remember exactly what it says, but it was something along the lines of keep exploring. So that's a good example of where 3D experiences really can elevate what the message of what you're trying to send to your user. Let's look at another practical example. We have a product page where you want to configure your bike and you want to, let me hide this, just check out your bike and put different colors on it. You can see it quickly and, spin it around and see what you're going to get. And also, one of the more important things on here, they have this like deconstruct option where it shows you what your bike looks like when it's taken apart. And like, this is pretty invaluable when you're when you're looking to, fix your bike, or if you want to disassemble it and reassemble it. I think this would be pretty cool. Get IKEA instructions delivered like this. Seems like it'd make a lot of sense.
So can that work for real images, like not just drawn components, but like if each one of those is like a 3D image of a real part, does that still work within this?
Yeah, I think they actually are all individual components that were brought together. So like they probably had to do a rendering for like each little piece here, and then with a click of a button, like assemble it all back together. So I think this is a really good example of it when it's used correctly, just to let people really understand what they're ordering and what they're going to get. Let's look at another one. Last year, the Video Games Award had this experience launched where you could join in the browser and get a little avatar, and there's an experience with some instructions, but you walk into this room and you can jump around. You have like full control over it. And this was like really geared towards gamers because they just kind of would immediately understand how to navigate this world. And then playing on the screen is the Video Game Awards. And it's just incredibly immersive because you'll be there. And I'm the only person in this room now because no one, why would, the Video Game Awards already happened. Why would anyone else be in there? But at the time, there was like a scoreboard for seeing how high you could get on like these platforms on the side. And you can imagine just thousands of little people running around watching the experience up here. And I think this is kind of, you know, what Zuckerberg's trying to sell, these interactive online experiences. And they're all possible as, you know, JavaScript developers. We have the power to do some of these things ourselves. Like this would be quite the project, and it gives you the option to see like a third person, or you could see a fly. And you know, I'm actually controlling the little person down here. So again, another immersive experience where you really feel like you're kind of, it's not just a typical HTML CSS website. So looking at awards, looking at these examples, it can feel like super overwhelming. Like, where do I even start? I mean, these things are hard to build, but they're way easier than they used to be. And that's kind of what I want to get at today with this talk is, you know, we're getting out of summer and into winter. We're going to have some days where we're stuck inside. And I cannot recommend a course enough. There is this website, 3JS Journey, and it was built by a French developer, Bruno Simon. And he has, you know, like 45 hours of video. When I bought it about a year and a half ago, he only had 30 hours, and he just keeps adding more and more. He is glued to the 3JS releases. When they come out with a new version, he'll update his content. It really is like, this didn't exist when I started learning 3JS, and it would have saved me so much time. So if this interests you, there's a code, Gary Simon 1, that you can use for 30% off the $95 course fee. So I'll, yeah, just make sure you write that down if you're interested at all. So for me personally, I've used 3JS at work and then personally just for fun, because once you learn how to build in 3D, it kind of opens the door to building more immersive things that you can share with friends and family. Like it's so much more fun to build something in 3D and see someone walk around in the world and explore it. And so I'll show an example of what we did at work. We had a client, and this was 3 years ago. So some of our styling updates since then have invalidated and made this look worse than it did before. We haven't maintained it because they didn't continue with the product, but we have a Dropbox for Deluxe Studios, which is they handle the post-processing for things like Avengers and all the Marvel movies. They also have a huge collection of TV shows and movies. And the problem they faced was that they would have assets that had, you know, they didn't know what that asset actually was. So they built something similar to Shazam or SoundCloud that would allow them to just, hey, give me the file and I'll find out what that actually was. Like, what is that? So back out a little bit. The thing that we built for them was a way to upload those files and then find out the associated media for that file. So I'll demonstrate that right now. So I have this Roku Final 2016. I don't know what that is. And I'm going to upload it, and then it's going to run the Shazam matching on it. And what they experienced was that takes a lot of time, and they needed some way to make it engaging for someone. So So we built this, and I tested this earlier in the video. It's supposed to display a video right here in the middle, but I think my IP isn't whitelisted. So I don't actually have the video playing, but you can kind of get the sense of what we were building, where you're kind of taken into the stream of analyzing that video file. And it took out a bunch of thumbnails from inside the video that you uploaded, and it's showing on the left side, it's trying to match what you uploaded to its existing database. So it's like scanning through, and it's like completely immersive, and you get the idea that you're kind of watching along as it finds the right match. Yeah. And here it finds the right video. It was Rogue One that I uploaded. And for brevity, I did not actually upload in 3 seconds the entirety of Rogue One, but you get just to get the idea of what we were trying to do. Another thing that they wanted was that if the audio was slightly off from the video, you could do this thing where you run a conform sequence, and that, I guess you can't hear it, and that's fine on here, but it's playing audio that's out of sync with the video player down here. And what happens is about a few, 15 seconds in, it tries to adjust the video and the audio to find the offset, and you can actually watch along as like that's happening. So these are the sound waves from the video that are off, and then in the end, they become matched. So that's an effect that we achieve through using Three.js. Yeah. Yeah, and so recently this summer I've gotten into disc golf. That's a weird segue. And I was trying to find a new disc to buy, and every disc golf disc has a like numbering on it that tells you how that disc will fly. Like it's speed, glide, turn, and fade, and like each of those numbers means something. But when I would go to a retailer, this was like their way of navigating those numbers. And this to me just like screams, opportunity. You can do something here. It doesn't have to be this way. So it was kind of a fun, project to work on for a couple of days of like, can I make this better? And initially I thought, just with CSS and HTML, but then I just took it to the 3D level, like where I want to know what these numbers do. How can I do that? And so I went and I just Googled Three.js golf ball simulator. And this is like a hallmark of a stable repo. Like, how much can you steal? And sure enough, this guy had built something that simulated golf ball flight. I was like, yeah, I can use this. Golf balls fly differently. They don't have the same physics for different reasons, but like there's a lot here with that I can kind of work on. So I forked his repo, which was 9 years old. And he invited me to. It's not like he didn't want it. It says fork on GitHub right here. And I just kind of, okay, let me refresh. It didn't look like this before I did StreamYard. Yeah, it seems like there's some issue with the resolution. Let me see if I can figure that out. Optimize this one. Okay. Okay, let me refresh. There we go. Okay, so I took what he built and I added some flight physics that I also Googled from like a paper on how discs fly. And quick aside, Frisbee, the name Frisbee, whoever wanted to know, it came from the Frisbee Pie Company, and they would deliver pies to Yale, but all the students would just throw the pie tins at each other. and they call them Frisbees because it came from the Frisbee Pie Company. So if that ever comes up in a trivia question, now you know. And so, yeah. So my idea was I have these drivers or like fairways or putter discs, and instead of looking at this, I can actually see. I click. I want to throw this right-handed, and it visualizes the flight path and shows a little mini map of. Can you guys see that line? It's kind of hard to see. Yeah. I can like turn around and you get an idea of like how far it can throw, and the way that these are put out from the manufacturers, they look like, where is it? I don't know where it went, but anyway, it looks like this. Like this is what you get. Huh?
You make the line like bright green.
I do, yeah. It looks way better on the screen. But so you get this line, which is supposed to show you how it flies. But when you can zoom in and watch the flight path in 3D, it just feels like you get the better understanding of what the disc can actually do. And so that was the driver right-handed. But if I want to throw like a fairway right-handed, I watch that one and I can see the flight path is much different. It doesn't go out as much. It doesn't come back. And you can kind of better understand the numbers. And that's kind of like the V2 is making it so you can like adjust the numbers and see what those do differently. But I consider the understanding and comprehension of being able to do this in 3D like super valuable and also just fun. Like this was a project I did in like 2 nights, and I just am so happy that I learned Three.js because I've had these ideas before that I've wanted to implement, and like now I feel empowered to do so. And it honestly is way easier than it's ever been, mostly because of how easy it is from this course, from this Bruno guy. So again, I strongly recommend. And for those of you who, I think a lot of you have probably seen this before. This is his portfolio and his like resume, and it's interactive, and you can drive around and learn about him, and you can like go and see his projects, and like they're up here, and you can drive over and hit enter to open up his projects. It's like such a cool. He calls it a resume, but like, come on. So yeah. That's kind of just what I wanted to say. Like it's so fun to learn it, and it's easier than it's ever been. And if there's a lot of inspirational stuff out there, and I hope maybe someone's inspired to take it up and learn it over the winter break. So that's it. Thank you.
Yeah. So I got two-part question.
Yeah.
It seems like there's 2 things that happen a lot here that you really need to dig into. I'm just like trying to figure out how much that's true. Art and math.
Yeah.
Like how much
Definitely.
is like finding an art when you're designing this for your company? Is there like a 3D artist who's actually like they're designing the process and you're going in and kind of building on top of that?
Yeah. There's definitely a good amount of math, but I wouldn't consider it overwhelming. I wouldn't say I was like a math genius by any means, but I was able to figure out how to do things in this with just some time. And then art, it's gotten way easier. What's the website, like Sketchfab, I think, is where you can go, and there's just you can go and buy 3D models, but there's also, it's not just buying 3D models. There's a lot that are just posted here that are available for free, that you can go and download this. And the best way to download, there's a file format that's used, GLTF. Those are the best to upload. And actually this course, Three.js Journey, that gets into how to actually build those assets in Blender, which is free. So it's a rabbit hole. You definitely can spend a lot of money on these assets or try to find cheap ones. Yeah, there's some learning. Yeah, hope that answered. Yeah.
What does 3JS compatibility look like on mobile browsers?
So it's compatible. This resume website works completely like without problem on your phone. But whenever I load one of these websites, my computer sounds like it's about to take off. There's definitely optimization that you have to pay attention to. You can't go to Sketchfab and get a model that has 60,000 triangles. You need to kind of limit what you're bringing into the browser because there are concerns over performance. Most sites that use 3JS have some kind of loader on the front end that will take a little time before you can get into the content. That's where we are right now because it is more resource intensive for sure. Also, on that note, it's not super friendly for disabled people. Yeah, there are accessibility concerns for sure. Yeah. Oh yeah, just going in order.
But it kind of ties in.
Okay, yeah.
Sorry. Along with that, the performance of the actual network build is something like this. Like realistically, obviously a full interactive environment, but
Yeah.
it says software you can have a little flashy thing on a landing page. And it's
Yeah. Like how much has the world heated up because GitHub put this on their homepage? Yeah, and for sure that's a concern. And I think that's why a lot of the time you see 3D implemented, it's kind of a background element. It's not super interactive, or it's kind of a side piece to the main content. And I think that is because it is resource intensive. But you see here, they were able to get the globe loading and add a lot of complexity and interactivity to their site, and it's still only 3.2 megabytes. So I feel like there's opportunity for it in so many places. Yeah. Yeah, definitely. So here's the disc golf simulator, and what we have is this is the main JavaScript, and we have options that you use to make the shot line. And so like for the driver right hand, backhand, like that's the driver shot that you saw, I'm setting certain values to generate the path that you see when the line is drawn, because that path is generated and then it's drawn. So all of the options that go into generating that line are set here. And then I call begin shot, which will use those options. And that's on a different page over here, shot. And there are some things, like here's the math part, like you have to, air density and gravity magnitude, like there's some math here, but if you, I promise it's not that hard to understand. Like they are, it does go back to like high school math where you're looking at a path and it has magnitude, it has a direction, and what happens is it runs on a loop, and as time goes by, you apply this gravity magnitude to the y coordinate, and every time the animation loop runs, it's taking the y that's being generated by the y, like the y coordinate, and it's multiplying it by negative 9.8, or taking away from it. So it starts off on that arc, and then it's slowly going down because of the gravitational magnitude. And again, this is where something like I wouldn't have known how to do this if I didn't just Google golf simulator 3JS, and like a lot of it's there to to take and to learn from. It's a 10-year-old library. There's examples out there for so many things in YouTube videos. So what happens is the shot projection happens, and then it just starts adding all of those variables to it, like the gravitational magnitude. Oh, let's see up here. So let me look where that gets added. So you take the vector and then you just like use that only one time, and it adjusts the acceleration of the, it sounds really complicated, but with 45 hours in that course, it becomes easier. Yeah, I promise. Yeah. Oh yeah, another question. Yeah, like the Google API. And actually, we had a project at work that someone in this room worked on that used the Google API and some version of like drawing on top of it to show ticket sales in different regions for movies that came out. And like you can actually take the coordinate values and draw them onto the map. And I think that's probably like something like what GitHub is doing. Where they're using little dots, you could instead use the Google coordinates in their API. I think that's totally possible. Yeah. And might be the guy sitting next to you who knows how to do that pretty well. Yeah. Yeah.
Does it like interface with VR at all?
It actually does, yeah. There are some awesome examples of people putting on VR goggles and being able to, you can build games in this, like first-person games, third-person games, or whatever. Like that Video Game Awards is like a great example of putting on goggles and being able to walk through that world. So, oh, and also like with the goggles, you see companies like Amazon and IKEA embracing that, where they're asking people, now that they have LiDARs in their phone, to scan their room and say, how is this furniture going to fit in my room? Throw on the goggles, check out how that couch is going to look in your living room. That's happening. Like people are building that right now. And it's hard to think that that's like kind of not going to be the future, to be able to visualize your furniture in your room before you buy it. Yeah.
Does BendJS actually do some of that, but some stuff as well?
Yeah,
Has it open VR?
it does. Yeah. Yeah, there's some VR content in their docs.
No, I mean like AR stuff, like you taking like the film video stuff and you're
Yeah, it's in here too. Yeah, it's pretty awesome. Yeah, and I can only feel like these skills are going to only become more valuable as people want more and more of these experiences. Yeah. Yeah.
Have you played around with Unity? I know it's not JavaScript, but like, would you potentially reach for that over this, or is there like a tipping point that you go from one to the other?
Yeah, that's a good question. Unity for sure, if you're building anything involving multiplayer, because over the web, you're still dealing with packets that come in instead of like a constant stream. So you're going to have wildly different experiences with someone else playing the same game as you. It's really a huge drawback for anything multiplayer. I haven't dived into Unity. I've just kind of heard that. So that's my answer. Yeah.
Speaking of this, I was just looking at this pipe, I caught it lightly. They actually say there's a thing, that pipe was offered in Unity, exported to BendJS.
That's awesome.
Using Needle.tools.
Oh yeah, that's my favorite.
So their technology, I guess,
Yeah.
takes Unity stuff and can export it into this 3JS.
Yeah, like most of the 3D modeling software will export to that GLTF standard, and that's what you're buying on the different 3D buying sites. And so the free version is Blender that I've had experience with because I'm cheap, but yeah.
So you can take that and just, it's doing the rendering and interaction with your JS. That's what really like a scene.
Right. Yeah. So the guy who built the tutorial, he built this, which is my room in 3D, and he built most of these assets using Blender. So like these didn't exist before he built them, like this little octopus on his couch or whatever. And then he added lighting in 3JS, and you can control all that. And he live streamed this. Like this isn't, deeply hidden stuff. You could do this. There are a lot of examples and demos where people did the same thing, where they wanted to build their room after watching him on Twitch. Yeah. Oh yeah, and he's got his resume up here. Yeah. 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 Oh, cool. Awesome. Cool. So that's, any more questions? All right. Thank you.
We had one more planned, but right over time, Ryan, thanks for being a good sport and pushing that for the next time.